We want to bring a joyous experience of mathematics to the world. And we want to prove that curriculum mathematics, the mathematics of the curriculum, the math that kids actually experience in classrooms, is its own joyous portal to awe, wonder, intrigue, delight, and human connection. We brought together about 300 people from across the planet just on social media saying, we want to be an ambassador to this project, spread the word. And our first year, 1.7 million students.
Today, we bring back one of our very first guests, James Tanton, back onto the Making Math Moments That Matter podcast. We love talking to James because he is so passionate about the discipline of mathematics, and he has some exciting, timely news to share with all of you.
We chatted with James way back in episode number 6, where we discussed his math background, his memorable math moment, and his passionate views on mathematics. If you haven't got a chance to listen to episode 6, you should jump over to that episode right now and give that a listen. Then come on back here to hear James talk more about exploding dots, how teaching polynomial division is the same as multiplying in grade 5, and vice versa. And he fills us in on Global Math Week and how you can get involved.
Let's get going! Welcome to the Making Math Moments That Matter podcast. I'm Kyle Pierce from tapintoteenminds.com.
And I'm John Orr from mrorr-isageek.com. We are two math teachers who, together,
with you, the community of educators worldwide who want to build and deliver math lessons that spark engagement,
fuel that learning,
and ignite teacher action. John, I am super excited for this episode with James. It's round 2 with Mr. James Tanton. Are you ready to go?
Of course, Kyle. But before we get to our chat with James, we want to give a quick shout out to one of you math moment makers. That's right. This listener left us a 5-star review on Apple Podcasts.
Whoa, that's pretty spectacular. This one was left to us by USMC, who says, thought-provoking, must listen for math educators.
I love listening each week, along with my daughter who is in kindergarten. This show offers insight into the classroom experience of many teachers, and the interviews always leave me with something to ponder over the week. Kyle and John have inspired me, and I often borrow ideas, tweaking them from my elementary classroom. This podcast is a must-listen for any teacher of mathematics.
Wow, thanks so much to USMC for posting this 5-star review and for hitting that subscribe button. Where are you listening in from? It looks like we've got some great reviews from both Canada and the United States. But how about you over in Australia? Great Britain? Represent your part of the globe by writing a review on Apple Podcasts or whatever podcast platform you're listening from.
Before we get to the interview, we also want to let you know that last week's guest, Christina Tonnevold from Build Math Minds, is running a free webinar training called Math is Not a Worksheet. Registration is open now until October 12th, 2019. You can register by visiting makemathmoments.com/buildmathminds. Again, that's makemathmoments.com/buildmathminds. If you're listening to this after October 12th, 2019, then that link will either bring you to the webinar replay or a waitlist for the next webinar.
All right, that's it for now. Let's dive into the chat with Mr. James Tanton.
Hey there, James. Welcome back to the Making Math Moments That Matter podcast. We've had a number of guests since you, and we usually have our guests tell us a little bit of something about themselves, but you've been here before. You were back with us in the beginning in episode number 6. But before we get into that, how are you doing tonight?
Oh my goodness, I'm doing so well. And first of all, thank you for having me back. I'm honored to be back. What a joy, what a pleasure, and what a real honor. So thank you.
Oh, it's so awesome to have you back. It's great hearing that fabulous voice of yours. And I know people at home probably are thinking, oh, James is back all the way from episode number 6. We are super excited to have you here. And as John was mentioning, we've already heard your memorable math moments. So we're going to ask you something a little bit different, and it's going to be based on something that John likes to do during his math fight presentations. John, you want to cue James up for what you have in store?
Uh-oh, what's in store for me? What's going on?
We're going to put him on the spot here. And actually, he's probably going to put us on the spot a little bit. But you have probably heard, people listening and James, about this game, 2 Truths and 1 Lie. Most people play it as a nice kind of breaker game. But in my class, I have used it many times to talk about different concepts like, say, quadratics or linear relations. And kids make 2 true statements.
As one naturally does.
Right,
yes.
Right. This is just natural in a math class.
Just in their spare time.
Kids would create 2 truths and 1 lie about, say, an equation or a graph, and then their classmates have to try to figure out the truths and the lie. But we're going to ask James to give us one kind of run through here. James, would you tell our audience and us 2 true statements and 1 lie about yourself, but do not tell us which one's the truths or lie, and Kyle and I will try to figure that out. And the people at home will also try to figure this out. Do you have something up, James? Can you give us a challenge here?
Well, okay, on zero notice, here goes. I, James Tanton of planet Earth, have climbed the highest peak of 2 continents on this planet. I have appeared on the game show Wheel of Fortune.
Ooh.
Everything I say is the truth.
Oh, man.
Oh, my goodness. This is fantastic. Well, I feel like Wheel of Fortune should be the lie because I've seen every episode of Wheel of Fortune and I would have remembered you. I know it.
Mm-hmm.
I don't know. John, what do you think?
Wheel of Fortune, the Wheel of Fortune one? I'm not sure. I'm going to say true on the climb to highest peak. James is always posting his mini hikes and his hikes on his Facebook page, and I see him hike every single day. I'm going to say true on that. Now, he threw a monkey wrench into this, Kyle. You've got to do some logic right now.
I know.
He says everything I say is the truth, which means one of the other 2 is a lie. Then what does that mean about Isn't that the lie? Oh, man, he's just mind-blowing.
This is tough.
Oh, my God.
This
Mathematical and math podcast?
John, do you think he's trying to pay us back for putting him on the spot with our 2 truths?
I think so.
I think we might have an issue here.
Yeah. What do you got?
Oh, which you was that? You was that me?
No, Kyle. What are you leaning towards here?
I think unless he's just not playing the game appropriately, everything I say is the truth has to be the lie. So I'm going to go with that one. John, I liked your logic here. It's going to be really embarrassing if we're like reading into that completely inappropriately. James, everything you say is the truth is your lie. What do you think?
Well, it has to be, does it not? Because
he's not tricking us. He's not tricking us.
Right.
So, by pure logic, had to be the lie. If I'm playing a game that must include 1 lie.
Right.
Well done.
Oh my gosh. So before we move on, I need to know, James Tanton, do you have any episode information about this Wheel of Fortune? Because I am I'm curious.
We are going to put it in the show notes right now.
Okay. Well,
we'll leave it embedded if it's on YouTube for sure.
Okay. The fact is, when I was 18, turned old enough to appear on a game show, I did appear on Wheel of Fortune, the Australian version, way back. Oh gosh, 20 or 30 odd years ago. So crazy amount of time ago in another continent. Yes, it was the cheaper version. I did not meet Vanna White. I did not meet whoever the host is of Thingy. But here's the thing. I actually did not know how the game worked. I never actually watched an episode. It was just a complete lark that I signed up for this thing, went for the interview, and got on. So I just did it. It was a blast.
That is fantastic.
You know what we're going to do? I'm going to search that up on the internet as soon as we're over here. I don't know if we can find it, but I'm going to search it. And I want to, like Kyle said, I want to put it right here on the site if we can.
Hang on. But one thing, I have to call Kyle on one thing.
Okay.
So I'm not actually an athletic person. Talk about that mountain climbing business. That's very recent in my life. I am not at all an exercise person whatsoever. The fact is, I happened to climb the highest peak in Australia, which is pretty darn small, Mount Kosciuszko. And then I was lucky enough to climb Mount Kilimanjaro one time. It took me 9 days to go up, and that was fabulous and fantastic. But it was didn't involve anything about pointy things on one boots or bits of rope or anything like that. It was just a nice, gentle hike all the way up. So it was pretty darn easy to climb the highest peaks of 2 continents.
Wow.
Will I go for any others? No, because I'm not athletic. I'm far from athletic.
You're still lapping me on climbing mountain peaks. And like John was saying earlier, yeah, you're getting out there in Arizona and you're climbing whatever's out there. I know they're not too tall where you're from, but you know what? I'm sure it's a good afternoon hike there for you.
Correct, exactly. So I've hit my 50s, so I figure I better start exercising in my life. So what I do is I go climb a little bumpy thing in Phoenix, Arizona. And there's so many bumpy things around. I just climb to the top of it and I'm done.
Awesome.
Fantastic.
Awesome. Well, James, we wanted to have you back on the show for 2 reasons. One is your enthusiasm and joy for mathematics is so contagious. You always share with us how human mathematics is, and you always give us new insights into thinking about mathematics. And 2, we wanted to talk to you about the Global Math Project and exploding dots all over again. We didn't get to talk a ton of time about those kinds of things on your last podcast, so we wanted to kind of dive into exploding dots and the Global Math Project.
Well, that sounds brilliant. I'm in. Yes, is the answer. What would you like to know?
Let's start with exploding dots. We talked a little bit on the last podcast, episode 6. So people, if you have not listened to episode 6, you're welcome to go back and listen to episode 6. But James is going to talk a little bit about exploding dots right now. James, where does exploding dots come from? What is this all about? Because
it sounds dangerous.
We've heard about this before. We've talked about it before, but let's get the lowdown on exploding dots.
Okay. So let's see, how can I begin this? So hopefully I'm consistent with whatever I said back in episode 6. The story begins this way. So as you said, I do believe that mathematics is a fundamentally human enterprise. We've been doing this thing for thousands and thousands of years, not because it's just practically useful, though it actually is, but also because it's enjoyable. It brings us joy and uplift to our hearts and to our minds. So mathematics is just an uplifting experience. And then in my sort of wayward career, which I must have talked about last time, I found myself being a high school teacher, which I absolutely enjoyed, but also found the most difficult and challenging job I've ever had in my life. School teaching is just undervalued because it's such hard work, but such important and valuable work. And I chose to go to the high school arena because I actually felt at the time that it was one of the most joyless arenas. This is, 20 years ago. So I think things have changed significantly since then. But, it was all about passing exams. That was the goal of high school teaching, get those kids into college. And it was like that get through mentality that I was really struggling with. How can I bring a sense of joy? And I found myself teaching these 10th graders, 11th graders, polynomial division. Polynomials. Okay, first of all, why? Why? When was the last time I used them in my everyday life?
Never.
And my background is actually research mathematics. As a research mathematician, whenever did I divide polynomials? Actually, you know what? Never.
And you've taken all of the math all the way up to the top.
Yeah, exactly. I've been all the way through it. And okay, it's not that this is not a worthwhile enterprise. I do know that it comes up in some interesting fields of mathematics, Galois theory and so forth, to know about how to work with polynomials and all the rest. But that's not of interest to 10th graders or 11th graders. So why are we doing this? So I realized back then as a high school teacher, okay, I've got to do something here. I've got to get my kids to pass those exams I had no control over, but really teach what I think is actually valuable. Not getting the answers to dividing polynomials, but actually understanding an interesting experience in mathematics that did fascinate mankind and humankind, but actually teaches the art of problem solving. And I had to think deeply about this. I said, well, really, polynomials are all about repeating everything you did in grade school, which was base 10, but let's just be a little bit looser about it. Let's just do it in a general base, in fact, an abstract base, call it base X. And voila, everything you do in high school maths about polynomials is just a repeat of grade 5, and no one tells you. It just happens to be base X rather than base 10. And in fact, if you let X equal 10, because people forget that X can actually be a number in algebra, that actually you are doing base 10 arithmetic. So I realized that polynomial division and polynomial algebra in high school really was about taking what you think you know or do know about base 10 arithmetic, which is a very human experience because we humans love base 10 because of our physiology. We have 10 fingers. We think 10 is rightly counting, but just being a little more loose about that and doing other bases as well. In fact, all bases, infinitely many bases, all in one hit. It's the story of place value and the power of place value and how that abstraction actually gives you a place of power to think through problems and how to solve problems. So again, it's one of these things I've always say, upper school mathematics is not about the content. No one actually needs to divide polynomials in everyday life. It's actually about using the content as a vehicle for teaching thinking. And the thinking here is the wonderful story of place value and the power that brings. So I decided, okay, I'm going to teach polynomial division through the story of place value. And that made me think about, okay, how do we think about and how do we write numbers? And again, it's back to our humanness. We love to think base 10. 273 is literally how we say it. 200s, 7T, TY is short for 10, and 3. And then I realized, actually, if you draw a picture of that, and this is where this dots and boxes idea comes in, actually draw boxes for the different place values of 10, and actually draw 2 dots in the tens place, draw 7 dots in the 2 dots in the hundreds place, 7 dots in the tens place, 3 dots in the ones place, you can actually see the number 273. And then all the grade school algorithms you do of it, long addition, long subtraction, long multiplication, long division, make perfect sense if you just draw the picture. And not necessarily have to draw the picture each and every time you do a computation problem, but once that picture's in your mind once, it's forever in your mind and everything makes perfect, good sense. And then suddenly everything makes the same perfect, good sense for high school polynomial algebra. So if it be base 10, it can be so being 110 and 1, it can be x squared, x and 1, and it's exactly the same work. And suddenly, these kids had a connected story of a human experience, which is we start with kindergarten math, knowing nothing. We learn how to count. We learn about the counting numbers. We learn how we humans are obsessed with the number 10 because we have 10 digits. But I don't know if you ever noticed, we call individual numbers in a number digits, and we call the things that ends our fingers and the hands digits because we literally are being human right there. And then all that stuff is about working in powers of 10 and just say, well, okay, Martians might have 4 fingers per hand. They'll do powers of 8. Computers actually even have on-off switches. They like powers of 2. It's all the same mathematics. So let's be abstract. Let's not be locked into our humanness and do powers of X. That's the story of upper school mathematics, just doing powers of X, and all the work is done in the same exact way. Now, it's very hard for me to talk about this on audio thing because it's all about the power of the picture. But suddenly, as soon as you draw a single picture, everything falls into place. And I call this exploding dots because, A, who doesn't like explosions? It seems to be a very popular thing. But the idea is that if you put, if I'm working base 10, as soon as I put 10 ones in one box, I realize, well, 10 ones we humans like to call 110. So actually, it's like 10 dots to, boom, disappear and replaced by 1 dot, one place to the left in the tens box. And then 10 tens we tend to call 100. So kaboom, they can disappear and be replaced by 1 dot, one place to the left in the hundreds box. That powerful mechanism actually is just, well, astoundingly powerful. I mean, you should use the word right there. It unlocks all the mysteries of those grade school algorithms, all the work I had to do as a high school teacher. So actually, what I love about this is that if we can teach 5th grade, 4th grade, 6th grade mathematics as sort of the visual power of place value, then those fabulous grade school teachers done all my work as a high school teacher because that's actually the same work as polynomial algebra, which is all the work I did as a college professor, because actually polynomials taken to another level, infinite polynomials are called series, it's kind of the same work all over again. It just connects all of mathematics in a wondrous way. So exploding dots is the story of seeing the mathematics of place value as one connected story from kindergarten, how we write numbers, how we manipulate numbers through grade school, how we actually work with polynomials all through high school, how we deal with infinite series and beyond in university and above. And you can get quirky and get into fractional bases and negative bases and irrational bases by just playing the same game that any kindergartner could play. It's just drawing a picture and you can see what happens and you get into these really quirky, wondrous things. Actually, there are unsolved problems still baffling mathematicians to this day. No one understands the mechanics of base 1.5. It's full of mystery. And any 3rd grader can actually play what I call a 3-2 machine, discover patterns, try to explain the patterns. If the patterns are true, they probably discover something brand new to the entire world of mathematics. It is just wondrous and amazing. So check out Exploding Dots is what I'm really saying here. Check them out. Google them, find them out.
And you know what? I think you did such a great job, even though it is such a visual experience. I want to even go a step further and say, like, I'm picturing back as you were talking back to your OAME talk, you did a keynote, and this must have been 3 years ago, 4 years ago, and you were using a document camera and you were doing the experience on printed slides so that you could actually do the experience live. And there's just something about actually doing the work of exploding dots that allows you to make some of those connections, right? And I know for me, even when I try to show a teacher, I'm like, no, we can't just show you. You've got to do the work. And I find that once people do, it's like they're just sucked right in and they don't want to stop.
So, Carl, you actually gave me more sophistication than I have. I didn't even use printed
It was
slides.
white paper and markers.
I use nothing. It's just let the math be itself. No technology, no bells and whistles. I'm not techno in any way. Just let the math shine for itself. Use nothing.
I remember nudging John next to me going, there's no way I could pull anything off like that. Like I like having my slides, and all this stuff. And like you're up there just giving her, in front of 1,000 people as you go. Obviously you had it all worked out in your mind, but it was like making it as you go, which was fantastic.
I do run this problem when people ask me to give talks. They ask me, so what equipment do I need? And I say, can I have a whiteboard? No. Can I have a chalkboard? No. Can I have like a bit of paper and a document camera? And that's hard. I mean, we live in this age now where everything has to be technology. And to me, I'm just like, no, just do it. Just actually have a hands-on experience. And I'll have the hands-on experience on stage. And that's very hard. That's very unusual in this day and age.
And the other thing too that was popping into my mind, I couldn't help but, when you had said going all the way down to when we're counting, something that's sort of, I guess, sad to me is that most young children know about the numbers in the teens and they know what it looks like. Like my kids knew what the number 12 looked like with digits symbolically way before they understood why there was 2 digits and all these other numbers. From 0 to 9, they all had 1 digit. And then all of a sudden, this one just has 2. And it was like, nobody mentions it. Nobody shows why. And kids just accept it, that's just the way it is. It's like almost like when they see 12, they see a 1 and a 2, but it doesn't look like a 1 and a 2. It looks like that is 12. And they don't even have this understanding of place value. And we kind of work through school. And then we talk about place value a little bit more later on. But now it's like trying to go backwards and really trying to unpack what's happening. So I'm wondering, as you're teaching in the secondary classroom and you run into this issue with trying to divide polynomials, like where did your exploding dots experience begin? Did it begin way down in playing with the base 2 machine or the 2-1 machine? Or was it way up there with polynomials and working your way backwards? Like, how did this sort of come to be? Was it just kind of little bits and pieces over time and you just over time filled in the middle? Like, I'm just curious for my own wondering, like, how did that sort of develop over time?
So you mentioned the number 12 a number of times. So before I actually answer your real question, let me talk about this. We in society are somewhat strange. We do allow ourselves to say 1200. That sounds normal to us, okay? But we don't let ourselves say 12T, 12 tens. So we are fickle in society. We're allowed to have 12 dots in the 100s box. We won't allow us to have 12 dots in the tens box, which is inconsistent. Even if we say a number like 112, we are literally saying 112 units. But we don't write 10, then the symbol 12. We actually write 112. We are terribly inconsistent in society. So the wonderful thing about exploding dots, it says actually the number 1012 is fine mathematically, 112 units. There's actually nothing wrong with it mathematically. Just society prefers to write 112, 100, 110, and 2. Because it just has a predilection for reasons that make no sense. I can say the number 12,000, 1,200, 12T12, and some of that sounds okay to you, and some of it doesn't sound okay to you. And why is society so inconsistent? So what we do to young kids is actually kind of bizarre and strange, and I have to say kind of cruel. So the thing is, we need to get the true story of the mathematics behind this. The math doesn't care about societal convention. 12,000, 1,200, and 12T12 is actually fine mathematically. Society prefers, yes, 12,000, feel free to say that. 1,200, feel free to say that. 12T, no, please make that 102 tens. So 120 and 12 we're allowed to say, but don't write that 12 there. Put another 1 in the tens place and a 2 in the units place. It's very, very confusing. So when I was a high school teacher, this exploding dot story. So what made me really think about this, actually it was percolating in my mind before then because I was doing some work in some math circle work with the idea of place value came up in different contexts as well. But this is a really subtle and confusing story. And I realized we do confuse students all the way through K through 7 and K through 8 and just make them conform without really thinking deeply about it. What I decided to do when I did polynomial work with high school is that, do you know what? We've never had the actual story of place value like really spelled out. And these kids have some mathematical sophistication. They're ready to look back at all that they thought they knew and see it in a brand new light. So yes, when I work with high school students on polynomial division, I do not start with polynomial division. That's kind of absurd to me. Let's talk about place value. So I do go back to the very beginning of my classic story. If you Google exploding dots, you'll see me say, when I was a child, I invented a machine. Not true. All this machine was you put dots in boxes, and it's called a 2-1 machine, blah, blah, blah. And we learn about this thing called binary, but I don't even say the word binary. We're just doing it for the sake of doing it. And then we'll do a 3-1 machine, and we'll just do it for the sake of doing it. Don't say ternary. And then we'll just go wild and go up to a 10-1 machine. We realize everything you do in a 10-1 machine is how we speak about numbers. And we realize, oh, these machines are place value, and actually that 2-1 machine is binary, which is actually used in everyday life in computers, because computers are based on electrical switches that are either like on or off. So they've got only like 2 fingers, if you like. And the 3-1 machine is ternary, and a 10 machine is base 10. And there it is. And these kids have never actually had the chance to take stock of what they've allegedly mastered and learned in the past. I mean, what is this learning process? I mean, we seem to have a curriculum that pushes kids through. And of course, think about how when you first learn a subject, you become familiar with the mechanics of the subject. You just develop some facility with those mechanics, which is fine, and you can do it, but you never had a chance to then reflect on what you're actually doing. But the curriculum says, oh no, you can do it now, moved on, check, you passed the exam, move on. But there's got to become a time when you realize, even though I'm familiar with the mechanics of it, I haven't really understood it yet. I haven't really internalized it. And that's the next process. What am I really doing? You start to question it. And then all sorts of interesting questions will come up, and you realize you had no opportunity to reflect on what you've been doing. You know, we so readily equate familiarity with understanding. One of my favorite things to say, because it's so true. We're so familiar with an algorithm because we can do it. It doesn't mean we've yet internalized it and really understood it. So I really felt it was absolutely important for my high school kids to have a chance to say, okay, you've just gone through the last, 10, 11 years of your schooling life about this place value stuff, but have you actually had a chance to now reflect upon what you're actually doing? So actually going back to the beginnings was essential, absolutely vital in developing deep understanding, in which case, by the time we get to the point of doing X1 machines, base X, well, everything's trivial. Like, okay, we get the story. Like, what's the big deal? There was no big deal. So if my colleagues, assigned me in this Algebra 2 or pre-calculus class, I can't remember what level I was at, 3 weeks to do polynomial division, I'll spend one entire lesson just talking about 2-1 machines, 3-1 machines, and the like. And I'll spend another lesson talking about 4-1 machines and then 10-1 machines. We'll talk about place value. And then, well, by the time we get to X1 machines at the end of lesson 2, we're kind of done. I mean, what's there to learn? It's all kind of trivial. So when you have a complete understanding, it's like, well, duh. Of course the math makes sense.
No, I completely agree here. And I did this lesson today. And so I had on the docket that we were going to get into polynomial division today with my grade 12 class. And for the last 4 years, I've been spending that lesson going back and redoing, grades 5, 4, almost like a history lesson on how you did division and multiplication and how they're linked. And then how, that relates to the exploding dots, but how that also relates to the area model and how you're getting the algorithms out of that. And like, no one probably told you that these things are linked this way or you can represent them in this way. And the eyes of the kids are just like, really like this area model, which they have touched on being in grade 12 back in grades 10 and 11, depending on which teacher they had actually, and you can just see them starting to connect the dots that the algorithms that they were shown back in grades 5 and 6 for multiplying and dividing are these exact same representations. And they're coming out, the algorithms come out of the work that exploding dots does, but also the area model is showing. Like you said, it's almost like a no-brainer once you go through that process and then you just say, okay, now we're going to use a quadratic and factor a quadratic. But then we say, now we're going to use a cubic and we're going to divide it by, a linear model or a linear equation. And it's a no-brainer. It was like, by the time we got to the polynomials, there was like 20 minutes left of class and I didn't have to do really any more examples. It was like one and it was done. And I totally agree that you don't have to, you just can do it with numbers and show them it's the same. It's beautiful. It's just beautiful.
Here's the scary thing, though. So we are so locked into base 10 that you won't let me say 12,1212 to 12. We always insist on carrying and borrowing. I don't know what those terms are. But in polynomial algebra, you don't care what base you're in. You have a coefficient of 12. It's fine. Have a coefficient of 8. It's fine. Have a coefficient of 102. It's fine. The fact is there's no borrowing and carrying in polynomial work, which actually makes it so much easier. It's like a fussiness of our society that insists that base 10 never have digits bigger than 9 in any one position, which is just actually annoying. It makes it so hard. Because suddenly you can reveal the true story of the mathematics by going to polynomials and being free of the whole notion of borrowing and carrying.
That's fantastic. And, just like both James, you had said, and John has said about how useful this is. So, sure, exploding dots, it's useful. Definitely do it. But there's a reason we wanted to bring you on to talk specifically about the exploding dots experience and joyous math. And that's because coming up real soon, like this week, when this episode goes live, we are going to be days away from this little thing that is known as Global Math Week. And, I'm not sure, but I think you might have something to do with Global Math Week. So I'm wondering, can you help us for those who don't know what Global Math Week, what's going on during Global Math Week? Tell us a little bit about it.
Okay, so here's another story. So my colleague, Jill Denise, just loved exploding dots. She said to me about 3 or 4 years ago, James, have you heard of this thing called code.org, this hour of code business, where they brought an hour of coding to the world back in 2013 or something like that, which has been tremendously successful. I mean, actually, brought computer science to classrooms all across the planet. And I think they declared a special week in October as well, actually, to be Hour of Code Week. And they just invited students just having a coding experience of some kind, whatever level they're at. If they know C++, go and do a C++ experience on their website, have a grand time. If you know nothing, just play with bits of paper and learn about binary. And great, have an experience. And they've been tremendously successful. I think they've reached something like 250 million students at this point. Jill said to me, we need to have something like this as well. We need like a global math week, something that's dedicated to mathematics, the joy of mathematics, and it should be exploding dots. And I said, yes, let's make it happen. Why? I can't say no to that. So we just declared October 10th to be the start of Global Math Week. It was a team of 7 of us that I put together to say, let's bring a joyous math experience to the world. This was back in 2017. It was our first Global Maths Week. We chose October 10th, the start date, because I happen to be an Australian and living in America right now, married to American, I was about to say as well. And I'm very confused about dates, because in Australia, I always said day and month. In America, you say month and day. So therefore, we chose the date that was palindromic, 10th of 10th. 10th of October, October 10th. I don't know how you read it, you're right. So, well, I have to say, we did fail on the math versus maths thing. So we are Global Math Week. Anyhow, we want to bring a joyous experience of mathematics to the world. And we wanted to prove that curriculum mathematics, the mathematics of the curriculum, the math that kids actually experience in classrooms is its own joyous portal to awe, wonder, intrigue, delight, and human connection. And it was clear, exploding dots, the story we should bring to the world that actually is that K through 5 through 8 through 12 beyond experience. So we just declared we're going to bring exploding dots to the world. So based on nothing, we are actually hopeless at public relations and hopeless at fundraising. We're based on nothing. It's all grassroots. We brought together about 300 people from across the planet just on social media saying, we want to be an ambassador to this project, spread the word. And our first year, 1.7 million students across the planet had an exploding dots experience with their teachers in the classroom. It just proved to us that having an opportunity to do joyous, genuine mathematics is a yes to our fabulous teachers across the planet. So we did it again last October. We're now at 5.5 million students, which is ridiculous. And these are just people, again, volunteering their own time and their own absolute passion and joy of mathematics to bring a joyous, passionate experience of maths with their fabulous kids. It's just all grassroots. It's just beautiful, beautiful teachers on our planet. So we're doing it again this year, 2019, October 10th, the start of Global Maths Week. Now, we have one little pickle that a lot of people think, okay, just have an exploding dots experience during Global Maths Week and they stop. But actually, Global Maths Experience is a year-long thing. Exploding Dots is a year-long enterprise. So we say we're going to try to bring the story this time around that start something during this week. Just have a wonderful experience. Share it on social media. Celebrate being part of a global community of teachers all across this planet who just celebrate joyous mathematics. Do something on social media. Share your wondrous thoughts, photos, videos, whatever you have that shows kids can love maths too during that week. But make it a year-long experience. So even if you're not ready to do something this coming week, even though Global Maths Week is around the corner, that is fabulous. Do something this year. Just check out Exploding Dots and have a fabulous, wondrous experience with your kiddos. And we're also starting to expand this a bit because many teachers have now done Exploding Dots a couple of times. And of course, that's fine because we all have a new round of students each and every year. But we started bringing some Global Math Project short experience as well. So we're starting to expand in other arenas. We've got a little thing about geometry, a little thing about probability theory, we've got a little thing about quadratics at the high school level that are short experiences, just shorter than Exploding Dots, in the Exploding Dots mindset. What is the human, connected, joyous, uplifting story behind this piece of curriculum that you can have with your students and see the maths you thought you knew in a brand new, astounding light. That's our goal. Let's share that with the world.
Awesome. We will definitely share that. That's why we wanted to have you on, is to share that and promote this as widespread as we can. And so if you're listening right now, please share some information that James is talking about. We want you to get into showing exploding dots in your classroom. Now, James, I'm wondering, you just talked about having short experiences, more longer experiences. I'm trying to help our teachers see how this could look in their classrooms. What kind of unique experiences have you seen teachers do? You said that, people are sharing online in social media, or maybe they're writing back to you or saying what they're doing in class. Could you give us a couple of examples of what it looks like in the class, start to end, for like a lesson plan, and then also maybe what that short one kind of looks like?
So first of all, I understand it can be very intimidating to do something new under very short notice. So one thing we do suggest is perhaps when you have half a class period, that will do it, 20 minutes. Give us 20 minutes, do with this with your kids, it'll be grand. If you go to our website, globalmathproject.org, you'll see a very easy way to start. That is, just go to that website and you'll see there a lovely animation. And all it really is a wordless animation that illustrates something about a 2-1 machine binary. I shouldn't say that now because it kind of gives it away. But show this animation for 80 seconds with your kiddos. That's all it is, 80 seconds, purely wordless with cute sound effects. And then do the classic, what do you notice? What do you wonder? Because it actually is intriguing, because you can't not notice something. You can't not wonder something about it. So have a chat about it. And then all I'm going to ask you to do is just please share your students' discoveries about this one little 80-second animation. Share it with the world. Just go on social media. What did your fabulous kiddos discover or wonder about? And just so we know about it, please, use the hashtag exploding dots or hashtag GMW 2019 for Global Math Week 2019 so we can recognize it. Then you'll realize that you're actually part of millions of students across this planet doing the same thing. In Serbia, in Japan, in Australia, in, Tanzania, all across the planet, because we really are in 170 different countries and territories at this point, which is amazing. You've got to admit, this is just stunning and beautiful. This is joyous mathematics transcending borders. This is global community united by the joy and passion of mathematics. And share that too with your students. Know they are actually part of a huge global community united by mathematics. That is just such a powerful, profound, and beautiful thing. And kids respond to that. So teachers do actually do that, and it's just beautiful. And when they see their posts and see other posts of other students doing the same sort of thing, brilliant. What's best of all is when students have their own questions or their own little puzzles that they make up based on exploding dots, they could write them up on a board, they take a photograph of that, and then post that. And they realize that actually students in other parts of the world start thinking about that too. And this actually is beautiful because it doesn't matter what resources you have. Some classrooms have the high technology, every student has a laptop and can play with a full web app experience, or other classrooms have next to nothing but it's just a rickety chalkboard. It doesn't matter. Whatever you have, you can think and share with the world and have the world see what you're thinking, see what you're asking, and respond to what you're asking. Because you know what? We are a beautiful global community. It transcends politics. It transcends borders. It just unites us all. And that is just stunning and beautiful. So,
James, that is so well said. I was so happy that you addressed the tech piece, because I go online and I look at the globalmathproject.org website and I can see this fantastic, beautifully done, organized tech experience that you can have through the friends at BuzzMath and Sunil and all the crew over there, Luke and many of the people that we know over there. Great people.
So cool.
Yeah, it is so cool. But on the other hand, too, I love how you literally have all kinds of great, just printable resources that you can pull out and you can literally just run it James Tanton keynote style by just getting that rickety chalkboard or, whatever it is. If it's that document camera or however, whatever they'll give you, you can run this. And the beauty is that the kids are just as interested no matter what the method. So it's not the tech, even though it's a beautiful experience on the web. I'm telling you right now, oftentimes I start just with that one video, that one animation, because that animation, that notice and wonder, like you said, it leaves kids and right away they're at it, because then The next part in the video sort of challenges them to try to figure out the code for this other representation of dots. And I think that's such a cool gateway to get somebody hooked in. And like John and I always say, spark curiosity, get them to lean in. And the next thing you know, kids are fueling their sense making with all of these ideas. And literally, like you had said, you could take this as far as you'd like to go. And if you feel restricted by the curriculum, you don't have to go all the way to polynomial division. You can go to where you think it's appropriate. But I know there's going to be kids in your class that are going to keep going whether you like it or not. And I think that is a fantastic thing when you have kids going home wanting to continue that.
I know this is sounding like wrapping up, but I have to tell one story then, because kids will go as far as they go, irrespective of you. Is a beautiful sentiment because something happened in Zimbabwe. One of the most beautiful stories we received was a school that had zero resources. I mean, the chalkboard was as rickety as anything. But one teacher did actually do an exploding dots experience, and they did the 2-1 machine, 3-1 machine, and 10-1 machine. They worked out how we write numbers as really place value. Those kids were so excited. The teacher went out during recess that day and found his class was digging holes in the ground, because of course they have just dirt in this particular school, and using pebbles they'd found, and his kids were explaining base 2 to all the other kids at that grade level in the playground during recess. They invented their own way of doing it. They just dug holes literally in the ground and used stones they found as the exploding dots.
Yeah. While you guys were chatting, I went to Twitter and typed in exploding dots, the hashtag exploding dots, and just scrolling. And I've got this amazing video in the title of the video from Simon Gregg from last year. It says a video of an alien explaining base 6. And it's a little boy. He's got to be maybe 5, 6 years old, and he's using chalk on the ground out in the play yard. And he is drawing the boxes and using a 6-to-1 machine and explaining how they're counting in base 6. And then the teacher kind of just says, now, how do we count on Earth? And then he redesigns it for base 10. It's pretty awesome to see, just, scroll through, like you explained, James, that you're going to see instances of teachers sharing videos of you explaining it right in Twitter. And also there's lots of info about this year's Global Math Week on the hashtag GMW 2019. Lots of stuff in there for teachers just to get started. It's going to be a great event.
Excellent. Well, thank you so much for being such supporters and believers in this project. It actually, I'm getting quite verklempt here because it really is just beautiful. I mean, I'm really just stunned that if you set mathematics free, you've set the joy of mathematics free. If you let mathematics shine for itself, it does. It's embraced by all of humanity. We have fabulous teachers across this planet. They believe in mathematics and set them free to let the mathematics shine with their kiddos. It just shines left, right, and center for one and all.
Well, James, obviously you are the right person to have at the front of this push to really, and it's not to make mathematics joyful, as you've already mentioned. It's bringing it out, and it's like we've hidden it for too long. So I really love that. And like John had mentioned earlier, your energy, it's contagious. We love having chats with you in person here on the podcast. And I want to make sure that those who are listening don't miss out on this experience. So again, the website is globalmathproject.org. We will link it up in the show notes. Also, don't limit your experience to your own classroom. Get your colleagues on board. If you're scared, we're all scared to try something new, just like James had said. Try with a colleague. Maybe do it at a staff meeting with all of your staff so that you can fumble your way through. I'm telling you right now, it's such a cool experience. And make sure that you're sharing whatever you do in the classroom with the hashtag exploding dots on Twitter. You can also use hashtag GMW2019. And be sure to tag the Global Math Project team at Global Math PROJ so they can get retweeting and sharing. So at this point, James, I think it's time for you to go climb a mountain, and we will catch up with you for the third episode that you'll come back on the show, hopefully in not too distant future.
You're so on. It's a real pleasure to chat with you guys. Thank you so much for all you do. It's incredible work, and I really appreciate it. Thank you.
Thank you, James. Thanks so much.
We want to thank James again for spending some time with us again to share the Exploding Dots Global Math Project experience with you, the Math Moment Maker community.
It was a great conversation. I know that I am going to be participating in the Global Math Week, and you too should if you haven't thought about it. get over to globalmathweek.org and get in on that action. Remember that Global Math Week is from October 10th to October 17th this year, 2019. And if you're listening to this in 2020, or maybe you're listening to this in like 2025, that would be crazy. I'm sure there's a math week then in October too. So get in on that. But before we end here, we want to let you know that last week's guest, Christina Tonnevold from Build Math Minds, is running a free webinar training called Math is Not a Worksheet. And I know this is going to be dynamite. Registration is open now until October 12th, 2019. You can register by visiting makemathmoments.com/buildmathminds. Again, that's makemathmoments.com/buildmathminds. If you're listening to this after October 12th, then that link will either bring you to the webinar replay or the waitlist for the next webinar.
In order to ensure you don't miss out on any new episodes as they come out each and every week, be sure to hit that subscribe button on iTunes or on your favorite podcast platform. Also, if you like what you're hearing, please share the podcast with a colleague and help us reach a wider audience by leaving us a review on Apple Podcasts and tweeting us at MakeMathMoments on Twitter and Instagram.
Show notes and links to resources from this episode can be found at makemathmoments.com/episode 45. Again, that's makemathmoments.com/episode 45.
Well, until next time, I'm Kyle Pierce.
And I'm John Orr.
High fives for us.
And high fives for you.